Hi guys, my name is M. Varun Karthik. I'm from Panimalar Engineering College and we did early detection of chronic kidney disease prediction using machine learning for IBM Nalaiyathiran program. And my team members are Saiba Agavaju, Shanmugavel and Santosh Prabhu. So, most of us are aware that nowadays chronic kidney disease is much more prevalent past few decades caused by unhygienic and unhealthy foods and sedentary life. If this disease is identified early, we can avoid life-threatening problems and can improve quality of our life. In order to get rid of this disease, we should change our lifestyle. We must avoid consumption of liquor, smoking habits, having unhealthy diets, and frequent usage of painkillers. Come on, guys, let's jump on to the working of the app. So, hi guys, now we are going to run our application. Before that, we will see my GitHub account. In my GitHub account, I uploaded all the required files for evaluation. As you can see here, let me go to my assignments. All the assignments are submitted. All the required files are here. As you can go for application building, you can see index, results, app, py, running the app image, proof for it. So now we directly go on for running of the application. I use here Visual Studios. Here we have a folder named flask CKD, which contains flask app. In that flask app we have templates. In templates we have index HTML, result HTML, and outside the template we have app flask app for running it, for rendering the page through server. And then we have a pickle file of chronic kidney disease prediction and model for it, and finally we have dataset. So here we move on to app.py flask app, where we can see we are importing flask render template request, importing numpy pickle request. So here you can see it is from basically after deploying we get this code snippet from IBM Cloud. It is we took this from here. Here you can see where we deployed in Watson Studio. You can see this is for integrating the IBM Cloud model with the Flask Python file. We use this, and then swipe down. We use this for at the end, like here. So then we load the pickle file, chronic kidney disease prediction.pickle. We reading it. First it goes to the index page. From index page, where we will get SG, specific gravity, hypertension, hemoglobin, diabetes, albumin, appetite, red blood count. All this we will calculate and get it from this index HTML page. You can see this values placeholders. It is given to this variable SG, HTN, hemo, DM. After that, these values are stored in array format to this values variable, and in paired scoring we will assign these values to these fields, and we will use cloud model for prediction of the app, prediction of the values, whether the person having disease or not. And straight away it is taking to result HTML, where in result HTML we can see if the prediction is 1, it is obviously true. You have a chronic kidney disease. If prediction is 0, you are safe. You don't have kidney disease. That's what it is storing. Prediction is stores whether it stores 1 or 0 depending on these values. So now let us execute the flask file. We are clicking here, and now it is running and it is executed. Now we run this HTTP. The file is opened. So we are actually in the page for kidney disease prediction. You can see here. Now I am giving some random values to check whether it is running or not. And you can see here our team name, product by our team name, and I am submitting here. Now you can see the result. So this prediction is actually for a person with a kidney disease. It shows a person having a kidney disease. Now from for with the help of dataset that person who don't have kidney disease, let us give that values and predict whether it is finding giving good accuracy or not. So 1.025 here 0, hemoglobin 13.8, diabetes 0, albumin 0, appetite yes, good, and red blood counts and the persons. Now we submit. See, you can see the prediction is 100% or accurate. It shows a person who is healthy, don't have chronic kidney disease. By this we conclude our app is working fine, very good. So now to my cloud account, this is my cloud account. So, and now going to the resource list, typing as, see, it is active, storage is created, the Watson machine learning default, it is active, and Watson Studio is active. Now I will explain about the Jupyter Notebook file, model file from beginning. Here we are importing libraries like pandas, numpy, seaborn, matplotlib.pyplot. Here pandas is used to deals with data frame manipulation, numpy for array manipulations, seaborn for advanced visualization, for graphic, where matplot is used for graphs. As as in Google Colab we don't use these. Why we imported these here means in order to read upload the file in IBM Watson and we read it from the Watson storage. Here we read the CSV actual CSV file and we are showing dotted showing first five rows of uh, CSV file. Now dropping the unnecessary feature ID which is unnecessary for our model. Dropping that column and we will look at the dimension of the CSV file and we are looking at the how many zeros are present in the futures, whole futures. It shows 9, 12. The age feature have 9 zeros. So then we describe it. The count, mean, standard, mean. That all is described here. Statistics. Actually, it is statistics. And the data types of each feature is shown float, object, float, object. Here we need to convert it to float in order for easily classify it. Here hit giving the value count, normal, abnormal, which is actually RBC having normal or abnormal, two types of values, which actually shows their count and their data types, how it is, integer or some other values, object. Same thing is done for every futures. And now see here, everything is in float. These three alone you can see it is in object. So we, in order to convert it to float, we use here pandas.2 numeric, and then we see here running. You can see everything is in float. Describing the data set. And the futures. The filling here, filna is used for filling the null values with the median value of this age. The whole values which is median for it, it is filled in the empty spaces. And then now count. Now seeing here, it is 0. Checking for null and you're plotting graph, visualizing the values, dropping PCV, now using graph, and here you use ilog for taking x and y in order to ilog used for taking rows and columns, particular rows and columns. And you use sklearn, importing this model, extract this classifier, and we are fitting the model and plotting values according to the top ranked features we took. Then head of those is given and tail of those is given. And now again doing the again splitting the data set into training and testing variables of test.3, which is 7030. Here we are fixing random state 33, which is okay if you are not also giving it. We're checking the performance matrix, how accurate our model is giving output. So random forest giving 97 and Adobe boost classifier 97, gradient boosting classifier 97. Everything is given 95. We are importing it as saving it as a dump file, pickle file using pickle.dump. Then we are installing Watson machine learning for IBM cloud deployment. These credentials are used, API getting API keys for integrating this scoring endpoint with flask. Space is created. You can see space success. You can see here. And then you can see software specification we using skikit-learn version 1.02, and then we are saving the model, getting the model details here. You can see here fields name and values, what should be their values. And finally you get model name, model ID, deploying that in cloud, which is now finally you can see successfully finished deployment creation. So that's it from my end. Thank you for giving me this opportunity for our team for creating this wonderful app, chronic kidney disease early detection. So thank you once again. Thank you.